Welcome back to TAE Certification Training Series. In the last session, we discussed the first three external TAS metrics, and today we will pick up where we left off and continue with the remaining metrics. Let's start with number 4, effort to maintain automated test. The maintenance effort required to keep automated test in sync with the SUT can be very significant and ultimately may outweigh the benefits achieved by the TAS. So you know how it takes work to make sure your automated tests stay up to date with your system? Well, sometimes dealing with all that work can be quite challenging. It might even get to the point where the effort you put into maintaining these tests is more than the good they bring, and that is not a good situation. The next point we have is, this has been the cause of failure for many automation efforts. So this problem is not just theoretical. It has been the downfall of many automation projects. If the maintenance work becomes too much, it can lead to the failure of the entire automation effort. And the last point we have is, monitoring the maintenance effort is therefore important to highlight when steps need to be taken to reduce the maintenance effort, or at least prevent it from growing unchecked. So to avoid this issue, it's crucial to keep an eye on how much effort you are putting into maintenance. When you notice that it's getting out of hand, that's your signal to take action. You want to avoid a situation where maintenance grows uncontrollably and becomes a burden. So to summarize this slide, excessive maintenance effort in automated testing can outweigh the benefits, often leading to project failure. So proactive monitoring and management are key to maintaining a healthy balance. Okay, so we are still continuing number 4, and the next point is measures of maintenance effort. Measures of maintenance effort can be expressed as a total for all the automated tests requiring maintenance for each new release of the SUT. So in order to understand this point better, let's do some calculation. If you have 10 automated tests, and each one takes 15 minutes to update, then the total maintenance effort for that release is 10 times 15, which is 150 minutes. So it's a very simple and clear way to express the maintenance effort required. The next point is, they may also be expressed as an average per updated automated test. If you have 10 automated tests, and the total maintenance effort for that release is 150 minutes, then the average maintenance effort per test is 150 divided by 10, which is equal to 15 minutes. So this calculation shows how you can express the average maintenance effort per updated automated test based on the total maintenance effort for the entire release. It provides a clear way to understand the average workload for each test. So we are continuing measures of maintenance effort. And the third point is, they may also be expressed as a factor of EMTE. We already covered factor of EMTE in the previous session. So if an automated test takes 15 minutes to update and 30 minutes to run manually, then the maintenance effort factor for that test is 15 divided by 30, which is equal to 0.5. So this example illustrates how you can express the maintenance effort for a particular test as a factor relative to the time it takes to run the same test manually. It's a clear way to understand the efficiency of automated testing compared to manual testing. Then we have a related metric is the number or percentage of tests requiring maintenance work. If you have 10 automated tests and 4 of them need to be updated for each new release of the app, then the number of tests requiring maintenance work is 4, and the percentage is 4 divided by 10 times 100, which is equal to 40%. This example effectively shows how you can use the number and percentage of tests needing maintenance to assess the stability and maintenance needs of your application after each release. It's a straightforward way to gauge the maintenance workload. Okay, so now choosing the appropriate way to calculate maintenance effort depends on your specific goals and the context of your testing project. Each of these methods provides a different perspective on maintenance effort, and the choice depends on what information you need and how you want to use it. Continuing metric number 4, the next point is role in decision making. When maintenance effort for automated tests is known or can be derived, this information can play a crucial role in deciding whether or not to implement certain functionality or to fix a certain defect. Let's try to understand this with the help of an example. So let's say that you are developing a mobile app and you know that updating automated test, it takes time. So if you have the knowledge about the maintenance effort required for your automated test, this knowledge helps you prioritize adding essential features. It also guides you in deciding whether to address defects immediately or in regular maintenance cycles. Next, we have the effort required to maintain the test case due to the changed software should be considered with the change of the SUT. So when you plan changes to your application, you consider the effort needed to maintain your test. This ensures efficient resource allocation and it keeps your test reliable. In this example, knowing the maintenance effort is essential for making informed decisions during app development. Moving on to metric number 5, ratio of failures to defects. A common problem with automated tests is that many of them can fail for the same reason, a single defect in the software. So consider that you have an e-commerce website with automated tests to check its functionality. A bug in the checkout process might cause multiple tests related to payments, order confirmation, and inventory management to fail. The next point is, while the purpose of test is to highlight defects in the software, having more than one test highlights the same defect is wasteful. So when these multiple tests fail due to the same checkout bug, it's like having multiple alarm bells ring for a single fire in the building. It not only consumes resources, but it also makes it harder to pinpoint the root cause efficiently. Then we have, this is particularly the case for automated testing, as the effort required to analyze each failed test can be significant. If each failed test requires investigation and fixing, dealing with a cluster of failed tests for the same defect can be very time consuming. It's similar to separately troubleshooting each ringing alarm in our previous example. Measuring the number of automated tests that fail for a given defect can help indicate where this may be a problem. Okay, so by keeping track of how many tests fail due to the checkout bug, you can quickly identify that this defect is causing multiple failures. This measurement helps you see the extent of the issue. And finally, we have the solution lies in the design of the automated test and their selection for execution. So to address this problem, you could redesign your test to be more targeted and selective. Instead of having several redundant tests for checkout, you might have one comprehensive test that covers all scenarios. This streamlines testing efforts and it reduces redundancy, making the testing process more efficient. So in automated testing, duplicated failures for the same defect are wasteful and it requires significant analysis effort. Measuring affected test highlights areas for improvement through thoughtful test design and selection. Next, we have metric number 6, time to execute automated test. One of the easier metrics to determine is the time it takes to execute the automated test. The time to execute the automated test is an easier metric because it can be measured directly by tracking the start and end time of each test run. Just to add on that, it is an easier metric, but not sufficient at it doesn't give other details like how many test cases were executed or how many defects were detected and how much code coverage was achieved, etc. So it needs to be used in conjunction with other metrics being discussed in this section. Next, we have in the beginning of the TAS, this might not be important, but as the number of automated test cases increases, this metric may become quite important. Okay, so in the beginning of the TAS, there may not be many automated test cases, so the time to execute them may not be very significant. However, as the number of automated test cases increases, the time to execute them may also increase, and this may affect the performance and efficiency of the test automation process. That's why the time to execute the automated test may become a more important metric as the TAS grows and matures. Number 7, number of automated test cases. This metric can be used to show the progression made by the test automation project. But one has to take into account that just the number of automated test cases does not reveal a lot of information. For example, it does not indicate that the test coverage has increased. Let's say you are managing a test automation project. You might be tempted to think that the more automated test cases you have, the better things are going. It seems like a sign of progress, right? But just having a high number of automated test cases does not tell you the whole story. It doesn't automatically mean that your test coverage, which is how much of your software is being tested, has improved. So it's a good metric to watch, but you should not rely on it alone to judge how well your testing project is doing. You have got to look at the bigger picture to understand your project's true progress. We will end our today's session here and continue exploring the remaining TAS metrics in our next session. Until then, take care.